Next type of Pfaffian differential equation, one variable separable. The previous type is what? Is a variable separable, means all three variables are separated in these examples. Already the example of one variable separable is covered before. What is that? The example is this. This is what? One variable separable differential equation. The given differential equation is integrable if you divide by this factor 1 plus z square x square plus y square to this differential equation, then it becomes y by x square plus y square dx minus x by x square plus y square dy 1 by z square dz is equal to 0. That is, z variable is separable. So one variable separable. Already what is the integration of how we can find solution of this differential equation? Here these x and y are not separated variable, and that's why by using some tricks we adjust this factor, these two variables in a such a way that we have its integration. So the next type is what? The first type is variable separable. That is, all the three variables are separated. For example, this example, if we divide this example by x square y square z square, that is multiplied by x square 1 by x square y square z square, then we have this equation. And in this, the coefficient of, if you observe the coefficient of dx, it is in terms of x. If you observe the coefficient of dy, it is in terms of y. And if you observe the coefficient of dz, it is purely function of z. And therefore this is three variable separable, and we can say it is a variable separable differential equation. And just integrating, we have the its general solution. These two problems are for assignment. Next type is what? One variable separable. So explain the method to solve the Pfaffian differential equation when one variable separable. It is one variable separable. The differential equation is one variable separable. So we have to discuss the general method. Suppose the variable z is separable in Pfaffian differential equation in three variables. Okay, so the Pfaffian differential equation is of the form. Now then, the given Pfaffian differential equation expressed in the form pxy dx plus qxy dy plus rz dz. Because z variable is separable, but x and y are not separated variables, separable variables. That's why we have this example, this type differential equation. That is the given partial, the given Pfaffian differential equation expressed in this form. For example, this differential equation. This is the Pfaffian differential equation in one variable separable. So if z, and the z variable is separable, so coefficient of dz is function of z purely, does not involve x and y variables. But the coefficient of dx is what? Is a function of x and y. The coefficient of dy is function of some function of x and y. So we assume that the given Pfaffian differential equation is one variable separable and z variable is separable in this Pfaffian differential equation. Then the given Pfaffian differential equation expressed in the form pxy dx plus qxy dy plus rz dz is equal to 0. The general form of the Pfaffian differential equation is what? Pxyz dx plus qxyz dy plus rxyz dz is equal to 0. This is the general form. But if the Pfaffian differential equation is one variable separable and z is separated, then we have, this is the form of the Pfaffian differential equation. That is, the coefficient of dx is the function of x and y. It is not function of z. And the coefficient of dy is the function of x and y. And the coefficient of dz is purely function of z. So we have this form because the z variable is separated. Then we write x bar as this pxyi, that is py plus qxyj plus rzk. Then find curl of x bar. Then it is what? Ijk, determinant ijk, divided by x, divided by y, divided by z, pxy, qxy, rz. Okay. Then divided by y of rz. This rz is the function of z purely, and so its derivative, partial derivative with respect to y is 0. Divided by z of qxy is again 0 because qxy is function of x and y, and so derivative with respect to z is 0. Minus j divided by x of rz is again 0, and divided by z of pxy is again 0, and then plus k Dabba dabba x of this is, what is it? Either it is dabba q by dabba x, and this is dabba p by dabba y, because this p and q are the function of x and y. Then what do we have? We have the curl x bar is k bar in bracket dabba q by dabba x minus dabba p by dabba y. And then x bar dot curl x bar is what? The multiplication of coefficient of I, pxy into 0 is 0. Then qxy into 0 is 0. And plus rz, the coefficient of uh, k bar is rz, into this is the coefficient of k bar is this dabba q by dabba x minus dabba p by dabba y is equal to, this is the curl x bar rz in bracket dabba q by dabba x minus dabba p by dabba y. The given differential equation, the given differential equation, this one variable differential Pfaffian differential equation is now integrable. When it is integrable, any Pfaffian differential equation is integrable if curl x bar dot curl x bar is 0, and therefore this equation star, the Pfaffian differential equation, is integrable if x bar dot curl x bar is 0, means this is equal to 0. That is if and only rz in bracket dabba q by dabba x minus dabba p by dabba y is equal to 0. If and only if rz is not equal to 0, because if rz is 0, then it becomes a two variable Pfaffian differential equation, and this is not the two variable Pfaffian differential equation, this is three variable Pfaffian differential equation. So rz is not necessarily 0, and therefore we have dabba q by dabba x minus dabba p by dabba y is 0, and therefore dabba q by dabba x is equal to dabba p by dabba y. And therefore the given differential equation pxy, not given, the differential equation pxy dx plus qxy dy is equal to 0 is exact differential equation, because this is the condition of exactness. When this p dx plus q dy is equal to 0 is exact, cancel this, write this differential equation is what? Pxy dx plus qxy dy is equal to 0 is exact differential equation. When it is exact differential equation, if the coefficient, if the derivative of coefficient of dx with respect to y, that is dabba p by dabba y, and the coefficient of the derivative of coefficient of dy, that is dabba q by dabba x, both are same, then the given differential equation is exact. That is if this differential equation is exact. When this the given equation star is integrable, now the given this equation, that is pxy dx plus qxy dy is equal to 0 is exact differential equation, because we have this condition. And then by definition of exact differential equation, suppose the differential equation is exact, this differential equation pxy dx plus qxy dy is equal to 0 is exact, because we have this. And when we say the differential equation is exact, if there exists a function v of x and y such that its derivative, complete derivative of that v is pxy dx plus qxy dy. So this is the definition of exact differential equation. So how we can check that differential equation is exact? For example, m dx plus n dy is equal to 0 is exact if dabba m by dabba y is equal to dabba n by dabba x. And if the given differential equation of two variable is exact, then there exists a function, some function of x and y, such that its derivative is m dx plus n dy. Here m and n are replaced by p and q. So if the function differential equation is exact differential equation, then its LHS is equal to the derivative of that function. Okay, so if we observe this one variable function, differentiable function, this, so this part, this is a function of x and y dx, this is function of x and y dy, and this is what? And this is the derivative of this minus tan inverse y by x. This is the derivative of tan inverse minus tan inverse y by x. That is, this is the v function. Its derivative is this. Okay. So like that, here is the, in general discussion, that function is v. So once the function is differentiable, differential equation is exact differential equation, then we have a function such that its complete derivative is this pxy dx plus qxy dy. Using this value of pxy dx, qxy in the equation star, we get, that is substitute this pxy dx and plus qxy dy as dv plus rz dz, and then just integrating. we have the integration of dv is v plus integration of rz dz is equal to constant, and this is the general solution of the given differential equation. So same procedure is applied here for this example. That is, once the z variable, one variable is separated, then adjust the remaining two differentiable functions in a such a way that is find v. Dv is equal to this dv is equal to this function. This is the derivative of this complete derivative of this v function, and then after integration, the integration of dv is what, v plus integration of that rz function as a tan inverse z in this example. So that's depend on the function rz. So this is the general solution. So if the Pfaffian differential equation is one variable separable, then just separate that variable and find the function v such that its derivative is the remaining function, and after integration we have the general solution or complete integral. So example on this one variable separable, show that the differential equation, this differential equation is integrable and find its general solution. Or another question is what? Just solve this differential equation. So the given differential equation is Pfaffian differential equation. Comparing with this the differential equation with p dx plus q dy plus r dz, and then find then write x bar as pi plus qj plus rk, and then find curl x bar, and then find x bar dot curl x bar, and it is equal to 0, and therefore say that the given differential equation is integrable. That part is uh, the the part of this x bar dot a curl x bar is equal to 0, right? That part, and then write dividing by x square minus z square into y square minus a square, that is or multiplying by 1 divided by x square minus z square y square minus a square. So what do we have? X by, we have the coefficient of dx as x by x square minus z square dx plus y by y square minus a square dy, and minus z by x square minus z square dz is equal to 0. And this is one variable separable. So y variable is separated in this example. So x and z are mixed variables. So y is separated. So and the two factors, this x by x square minus z square dx and minus z x square minus z square dz, take x square minus z square as LCM. So we have x dx minus z dz divided by x square minus z square plus y by y square minus a square dy is equal to 0. So this is the one variable separable differential equation. Y variable is separated in this differential equation, Pfaffian differential equation. Now we have to find the integration of this factor, and that we have to find the function v such that its derivative is this function, that x dx minus z dz divided by x square minus z square. And in order to find the function v, use these tricks of the chart. So if the differential equation is one variable, then separate that variable and use these tricks. So what is the tricks? That x dy minus y dx divided by x into y is the derivative of log y by x. Similarly, x dy minus y dx divided by x square plus y square is the derivative of tan inverse y by x. Or adjust the derivative of numerator, denominator at numerator. Okay, so use these tricks. So in this example, the function is what? So in this example, the function is what? X dx minus z dz divided by x square minus z square. So apply that tricks, or adjust the derivative of denominator at numerator and use the rule of integration, that is integration of f dash x divided by fx dx is log fx. So what is the derivative of x square minus z square? Is 2x dx minus 2z dz. So just multiply by 2 and divide by 2. So what do we have? 1/2 in bracket 2x dx minus 2z dz divided by x square minus z square, and this function as it is y by y square minus a square dx. And this bracket is the derivative of log x square minus z square by using rule integration of f dash x divided by fx. So if you find the derivative of log x square minus z square, it is what? 1 by log 1 by x square minus z square into derivative of x square minus z square is 2x dx minus 2z dz plus y by y square minus a square dy, and then integrating. So 1/2 integration and derivative of this log x square minus z square is log x square minus z square plus integration of y by y square minus a square dy is equal to 0. Again, if we find the derivative of y square minus a square, then it is 2y. So already y is there, so multiply by 2 and divide by 2, and then the integration of 2y divided by y square minus a square is log y square minus a square is equal to constant, and therefore we have the solution multiplying by 2 log x square minus z square plus log y square minus a square is equal to 2c. Suppose we denote 2c by c1, or next step is what? Log a plus log b is log a into b, and then shift the log, then it is e raised to 2c, and then substitute denote this e raised to 2c as new constant c1, and so x square minus z square y square minus a square is equal to c1 is the general solution of the given differential equation. Or in order to solve this differential equation, this part, x by x square minus z square dx plus y by y square minus a square dy, we apply the method of exact differential equation. This is the exact differential equation. Once the given differential equation, Pfaffian differential equation is integrable, means this mixed two variable differential equation is what? Is exact differential equation. And if the given differential equation of two variable is exact, then its solution is what? The formula for its solution is what? Integration p dx plus integration terms in r independent of x dz is equal to 0. So actually the formula for general, if the differential equation is in this form, m dx plus n dy is equal to 0, where m and n are the functions of x and y. So when this differential equation is exact, this is the differential equation in x and y. So when this differential equation is exact, if dou m by dou y is equal to dou n by dou x, and once the differential equation is exact, then its solution is what? Integration m dx plus terms in n independent of x dx is equal to constant. So here the this differential equation x by x square minus z square dx plus y by y square minus a square dy, this differential equation is in the form pxz. The p is the function of x and z dx, and the q is again the function of this q. After simplifying, this is q, not this is q, this is q minus z, x square minus z square dz is the again the function of x and z. So if you convert this note in the form m dx plus n dz, okay, or p dx plus n dz is equal to 0, then what is its solution? Integration m dx, that is integration p dx plus terms in q independent r independent of x dz is equal to 0. So if you denote this is p, this is q, and this is r, then this p dx plus r dz become exact differential equation, and its solution is what? Integration p dx plus terms in r independent of z, independent of x, and the integration is with respect to z. And therefore what is p? P is x by x divided by x square minus z square, and r is minus z divided by x square minus z square. So this term, there is only one term in r, and it is depend on x, and therefore in the place of these terms in r independent of x is 0, dz is equal to 0. So there is no term in r which is independent of x, and therefore it is 0 dz, integration 0 dz is equal to constant. And then by using the rule of integration, that f dash x divided by fx adjusts to the derivative of x square minus z square is what? Is 2x. With respect to x, the derivative of x square is 2x. and the derivative of z square is 0. So multiply by 2 and divide by 2, and then we have the integration 1 half log x square minus z square plus 0 is equal to constant, and that is we have the answer log the integration of this factor, this two factor integration of these two factor, that is x by x square minus z square dx and minus z by x square minus z square dz is what is 1 half log x square minus z square. So we have this answer 1 half log x square minus z square by using this method, that is by applying the method of exact differential equation, or by adjustment we can find its integration. So next example of the same type, that x in bracket 1 plus z square dx plus y 1 plus z square dy x square plus y square dz is equal to 0. So first show the differential equation is exact is integrable by showing x bar dot curl x bar is 0. That part is for homework. So dividing by 1 plus z square x square plus y square, what we have x by x square plus y square dx, y by x square plus y square dy, and z divided by 1 plus z square. It is 1 divided by, there is only x square plus y square, so right here 1 divided by 1 plus z square dz is equal to 0. And again this is one variable separable, z variable is separated, and then adjustment of this factor is what, take x square plus y square as LCM, then x dx plus y dy 1 by 1 plus z square dz is equal to 0. And if you find the derivative of x square plus y square, then it is 2x dx plus 2y dy. So multiply by 2, divide by 2, that is adjust the derivative of numerator and denominator, the derivative of denominator at numerator, and then integrating we have 1 half, this is the derivative of log x square plus y square, and so its integration is log x square plus y square plus 1 by 1 plus z square is the integration is tan inverse z, because if you take x as variable, then what is the derivative of tan inverse x? 1 by 1 plus x square, like that. The derivative of tan inverse z is what, 1 by 1 plus z square is equal to constant. So this is the general solution of the given differential equation, or primitives of the given differential equation, or is called complete integral of the given differential equation, or solution of the given differential equation. So these are some problems for homework or assignment. All these problems are one variable separable Pfaffian differential equation, depend on the method one variable separable. So separate that one variable and find the general solution of these problems. So I think answer of some problems are also given here, but these answers are, all these problems answers are, there is some mistake in these answers, so solve independently and then check whether your answer and this answer match. So these 8 problems are for homework. So the next type, and we will discuss these homework problems in the next lecture. So first solve the problems. In order to find the integration of the two mixed variables, use these tricks. In order to, here is the correction, that x dx plus y dy, x square divided by x square plus y square is a derivative of 1 half log x square plus y square. The correction is what, x dx plus y dy. So next type is homogeneous Pfaffian differential equation, that is the third type. We'll see this next type and some problems of one variable separable in the next lecture.